Hey, this is Brock Lemires, and in this video I'm going to go over lab 3.2 on standard input. Okay, so the purpose of this lab is just to give you a little bit of experience playing around with the scanf function and reading in different pieces of information into variables. So you're gonna prompt the user for to enter information. You're going to bring it into data types that you set up of type int or as integers, floating points, and characters. Okay, so you should be able to very easily use int, double, and char data types after this, and also the scanf function in order to stick information into there. Once you're done, you're going to have a screenshot of your output results that you will have to match exactly what I give you, and then also your source code that you'll secure copy back to Windows. So just like every lab in Windows, start by making a folder on your C drive in your CSCI 109 folder called lab03p2_files. That's where you'll secure copy your source code back to and save your screenshot. And then once it's on Windows, you can upload it to Brightspace, and then go ahead and go log into the CSCI 109 server and create a folder called lab03p2_stdin, and that's where I'm at over here. And what you'll see is you're going to create a new source code called scanf_vals. Okay. And then just like everything, you're going to start by putting in a nice comment header that has your name, class, the lab, the purpose, the date. And then what I want you to do is I want you to create all of these variables. So you're going to have some variables of type char, some of type int, some of double. And then I want you to prompt the user for information that you're going to read in using scanf, and you'll stick into here. Okay, so here's what you're going to do. You're going to enter your first name. They'll enter it. How many bits are in a byte? 4. How many bits are in a nibble? 4. How many bits are in a byte? 8. And then once you read all this information in, I want you to print it so that it is exactly like this. And that includes the extra line return right here, the tab that it takes, the tab over here to make them all nice, also the speed of light in this format, charge of an electron in that format, and everything's good. So when you're all said and done, here's what it's going to look like. You're basically going to run scanf.int, and it's going to say, what's your first name? Brock. How many bits are in a nibble? There's 4 bits in a nibble. How many bits are in a byte? There's 8 bits in a byte. How many bytes are in a char? A char is 8 bits, so that's 1 byte. A short is 16 bits, which is 2 bytes. An int is 32 bits, which is 4 bytes. A float is 32 bits, which is 4 bytes. A double is 64 bytes, or 64 bits, which is 8. Speed of light is 3e to the 8. Charge of an electron is, the magnitude is 1.602 e to the negative 19. And there you have the output. So that's all your program is going to do. Just to playing around with getting the scanfs working, you might have to put a space in front of your format specifier. You'll have to play with that. And then you're going to have to play around with your formatting to get these all nicely lined up. And you can print these just like this. I want you to print the speed of light like this so that you have to use the precision option in the printf. Don't just throw it into scientific notation. So I want you to do it like this, okay? And then you have to put these labels on here for coulombs, meters per second, etc. And that is it. Once you're done with that, save that screenshot, secure copy back your source code, upload them, and you are done. Nice work.